Semiconductor industry started in Malaysia back in late 1960s. It is a very important industry in Malaysia today. In fact, semiconductor industry has contributed more than 1/3 of Malaysia's total exports. It is an industry bigger than oil and gas today. If you look at Malaysia's semiconductor industry, it can be divided into the front end and the back end. The front end is on the design and fabrications, and the back end is more in the manufacturing, assembly and test. Malaysia's semiconductor industry is focusing heavily on the back end, and there are few players in the front end. Oppstar is one of the few local R&D company that is playing in the front end.
We offer a full spectrum of IC design services, which comprise of chip architecture and microarchitecture, functional and logic design, circuit design, design verification, physical design, custom layout, as well as full chip integration. We offer these design services for complex ICs, such as CPUs, SoCs, ASICs, and FPGAs. Oppstar is strategically headquartered in Penang, which has a vibrant E&E ecosystem and is often regarded as the Silicon Valley of the East, while also operating from other offices in Shanghai and Kuala Lumpur.
We were incorporated in 2014, and we literally built this company from ground zero. We started with 3 employees and over the years expanded rapidly. As of now, we have 193 permanent employees. And when we first started, we were mainly focusing in the back end of the IC design flow. At that moment, we were mainly servicing MNC customers that has base in Malaysia. And over the years, we have evolved from the business model front and also technology forefront. For example, we have successfully completed projects based on 10 nanometer in 2016, 7 nanometers in 2018, and 5 nanometer in 2021. We have also evolved from providing specific design services towards turnkey solutions. Turnkey was not possible in the past because it needs sizable team and industry track records. Today, turnkey accounts for 79% of our revenue. We have also moved from servicing domestic market to becoming a global company, whereby more than 80% of our revenue comes from overseas.
The IC design flow starts with the definition of architectural specification and microarchitectural specification. For architectural specification, our architect team will communicate with the customers or marketing teams to define all the functions or features required in the IC. The microarchitectural specification mainly focusing on certain blocks inside the chip. For digital logic design, the engineer will start design the IP in RTL code using IC design language like VHDL, Verilog code, or System Verilog code. After that, the team will synthesize the RTL code into gate-level design by using industrial EDA tools and the design library from technology provider. Basically, computer and software convert our RTL code into gate-level design. On analog circuit design side, the engineer will design the analog circuitry in the form of gate-level schematic. The engineer will then perform simulation to ensure the design is functional according to the specification. In designing, it is crucial for the defects to be detected as soon as possible to reduce the amount of rework required. The design verification is a process to ensure the quality and functionality of the design. This is applied to both digital and analog design. After that, the team will create the test environment and generate tests to cover all the defined scenarios.
Custom layout designs involve translating analog circuitry from schematics onto complex geometrical representation of transistors and interconnects. The geometrical representation defines the physical placements of material onto layers that makes up all the transistors within an IC. Whereas in physical design, engineers use advanced EDA tools to transform gate-level netlists into logic functions through multiple processes to achieve optimum power, performance, and area of an IC. These processes are namely synthesis, for planning, place and route, as well as performance verification. On top of this, we provide full chip integration solutions and methods which integrate various functional blocks. For full chip integration, our design engineers are involved from an early stage of a project. This is to set the proper design guidelines for the development of each functional block.
The ICs we design are used in various industries such as telecommunications, automotive, industrial electronics, and consumer electronics. Oppstar's success is closely tied to our ability to design complex ICs based on advanced process nodes. These are made possible with our strong technical team supported by an experienced management team. Based in Malaysia, we have a multilingual engineering team that is able to provide support to our clients in the Asia-Pacific region.
Our future plans include, first, expanding our workforce and geographical footprints both locally and overseas in Penang, India, Singapore, and Taiwan. We will also look into business expansion through investments and acquisitions, as well as expanding our post-silicon validation services. For R&D, we plan to develop our own IPs for RISC-V-based SoC, IP for AI and machine learning applications, as well as IPs for FPGA. Lastly, we plan to expand our collaborations with local and foreign tertiary institutions. IC design industry in this country is pretty much dominated by big MNC, and we always believe we can build a local R&D company using local talent. And if we do it right, we can encourage more aggressive youngsters to venture into this area, and they were directly helping the country moving up the semiconductor value chain.
Oppstar, your engineering partner for excellence.